Okay, this video is for the chapter review of chapter 3. Now, as I told you in the introduction video, we didn't really get to a good place where we could quit that chapter, so I wanted to do kind of a wrap up of that and then kind of highlight some of the things that we need to know because some of that stuff will transition us into chapter 4 and we'll be beginning that unit next week. So, first thing I want to do is of that big worksheet that I gave you. I don't know how far you may have started, maybe not at all, but I wanted to go through and cross out a bunch of questions so that I get a chance to see if you can recall a little bit what the focus of what we talked about, and then we'll go from there. So on page 1 of the review, you can see I've crossed out questions 2 and 3 on the top of the page. Okay. On the back side of that worksheet, it says review exercises. You've got data on helmet injuries for skiers and ski boarders. Cross out number 11 on that page. The next page starts off with number 12, and it says National Statistics Day. We're going to cross out that whole page of questions, okay, 12 through 17. Okay, the whole page. On the back side of that page, again, cross out all of them. You got 18 and 19 on top. You've got 1 through 8 on the bottom. Cross all of those out. If I would have had a little more time to do some editing before I had to do packets there, I would have saved you the work of doing all these, but it is what it is, and we've got to do what we need to do so we can keep moving. The next page starts out with question numbers 9 and 10. They are both multiple choice. The majority, if not all, of the remaining questions are going to be multiple choice. And we're going to cross out most of the other ones. So on that page, cross out number 11. And we'll talk about some of those here in a little bit. The backside, 15 through 18, we're going to do all of those. (19) through 23, you can cross out number 19. You can cross out number 21. Cross out those two questions on that page. On the back side, you're going to cross out number 28 down toward the bottom. This is 24 through 29. Cross out 28. And then on the final page of this review, cross out all of those last 4 questions. Okay, cross out 30 through 34, or 33, excuse me, 30 through 33. Okay, so those are the problems that we're going to do. That'll give you a good overview of the things that I kind of want you to recall. I'm going to go through the problems on that first page and then kind of see let you go from there, and I'll just start addressing some questions as you can email those to me, and then we'll do more. So on that first page, these are all open-ended questions. Okay, that starts off talking about complement. Okay, remember we said that all of the particular arguments for a probability have to add to 1. All of those different probabilities have to add to 1. So if I know one value, then I can find the other. And one or the other, again, one's the complement of the other. So number 1 says, a Las Vegas handicapper can correctly predict the winning professional team 70% of the time. So what's the probability that this handicapper is wrong? So if 70% indicates the amount correct, then the amount left over, which would be 30%, would be the amount that person is incorrect. Okay? Number 4. When conducting a clinical trial of the effectiveness number 4 is going to be another one that we're crossing out. Okay? So, cross that one out. Okay? Number 2 is the one I wanted to leave in. Okay, and you'll see why here in just a minute. Number 2 says, if that same handicapper described in exercise 1 finds the probability that she is correct in each of the next 2 predictions. Now, this is a compound probability problem, meaning we have more than one event taking place, and, I repeat the word and, both events must happen. So we talked about or, we talked about and in probability. This is an and. So the probability of getting the first prediction correct is 0.7, 70%. Okay. The second event, same thing, 0.7. If you multiply those two together, the probability that both corrections are correct would be 0.49. So if you have multiple events happening, okay, and both events must happen, then it's a multiplication problem. When it's an or, you'll see one of those in just a minute, okay, then or means that one or the other, that's addition problem, and we'll look at that one. Number 5, again, this one is like number 1. If the probability of event A is 0.4, what's the value of the probability of the complement of A? Well, again, instead of a percent, this time it's a decimal. So the complement of the event you subtract from 1 would be 0.6. Okay? For questions 6 through 10, they take you through the same kind of things that we did when we went through the chapter, but they start off with simple events, simple single events, and then they move into compound, and then they move into some of the other probabilities, conditional probability. Okay? So on number 6, you notice in that table, and anytime you give a table like this, you want to fill in the row columns and the row totals and the column totals. For each one of these, in this group, I've got 586 total people. Okay, so you have 2 groups, Group A and Group B. Group A is a minority group, B is a majority group. You can tell by the numbers, and you can look at who passed and who failed. Okay, we're trying to make some conclusions about that. So if one person is randomly selected, find the probability of getting someone who passed. Well, this is where those row totals come in. Of all of the people that passed, okay, I can see there were 427 of them. Okay, 427 passed out of a total of 586. So if you take 427 divided by 586, I get 0.7286689. And remember, when we did these as decimals, we said round to 3 significant digits. That would be 0.7286689. So a simple single probability from an event. Okay, now let's step up from that. Okay, number 7 says find the probability of randomly selecting one of the test subjects and getting someone who is group B or passed. Okay, well, group B, when you look at the row total, group B was 562 out of 586. Or means this is an addition problem. Okay, passed is 427 out of 586. And here's what we did with these. When you have problems that are in tables like this, okay, and you're working with a specific row and a specific column, okay, we said that some of those values are going to be counted twice. So what I want to do is I want to subtract off anything where that row and that column intersected. So I'm going to subtract group B that passed would be 417 out of 586. Now, add and subtract the numerators, okay? You're going to end up with 572 divided by 586. If you divide those values out, I get a probability of 0.976. Now, notice I'm giving you the fraction form and the decimal form. It doesn't express how they would like those. So I would leave either form, either the fraction or the decimal would be okay with me. Okay. Number 8, find the probability of randomly selecting two different, again, a compound event, and finding that they're both in group A. Okay. Now, here's the key. These have to be two different test subjects. So that means that I cannot replace that person. Okay, remember we talked about with replacement and without replacement. Replacing means you put them back in, which means you have that chance of drawing that person again. Without replacement means I'm guaranteed a new test subject on my second selection. So they have to be in group A. I know that there are 24 people in group A. So my first pick, my first selection, I have 24 choices out of 586. Now, when I do my second choice, there are only, since I'm not going to replace that guy, there are 23 choices left over out of 585 test subjects. Okay, so 24 times 23 is 552. 586 times 585 is 342,810. And if I divide those, I get a probability of 0.00161. Okay, so if I go 3 decimal places, it's 0.002. If I go significant digits, it's 0.00161. Okay, either one of those. Okay. I can tell if you're doing them correctly by either of those answers. On number 9, so move it up here so you can see. Okay. On number 9, find the probability of randomly selecting one and getting someone who is in group A and passed. Okay. So because of the and, in this case, it's a multiplication. Group A is 24 out of 586. Okay. Passed is 427 out of 586. Okay, so do some multiplying again. Okay, so I got multiplied and then divided those to change it to a decimal. I got 0.0298. Okay, so again, determine what kind of a probability are they asking you to perform. An or, an and, or as you're going to see in this last example, okay, we also had what was called a conditional probability. Okay. So on number 10, find the probability of someone setting someone who passed, selecting. Find the probability of selecting someone who passed, given that the selected person is in group A. Now, what you want to do, this is where we talk about this kind of notation. Okay, so we want to find the probability of getting someone who passed, that's my abbreviation P, given that vertical line there is kind of a conditional line, given that they are a member of group A. So the first thing you do is you find out how many, combine the two events. How many people in group A passed? Okay, how many people in group A passed? Well, group A and passed, there was 10 people. Okay, now you divide that by the number of, or the value of the number in the given group. So I'm given group A. How many people are in group A? Well, there are 24. So 10 out of 24 is 0.47 as a 0.417 as a decimal. Okay, and then if you just reduce it, it's 5 out of 12 as a fraction. Okay, okay, but when you're doing conditional probability, the top number reflects both events happening at the same time. So in this case, again, someone who passed and in group A. And so when I go up and find that up here in the chart, passed in group A, that's how they got the 10. Okay, and the denominator, okay, then is just the amount of those that are given, which is group A, and then I use my row total, okay, to express that. Okay, so that's how a given a conditional probability works. Okay, one more real quick, and I'm going to end this video, and we'll come back to some other things here. On the third page, we didn't do much with this, and so it's not reflected in the other exercises. But this one, the top question is the multiple question number 9, multiple choice question. Number 14 is the one I want to look at because it talks about odds, playoff odds. Okay, and we didn't do very much with playoff and betting, but this is one I need to explain. So suppose you're playing a game of chance and you bet $10 on an event that will collect $500, including that to $10 if you win. Find the odds used for determining the payoff. Okay, so this is for a playoff event. So here's what I found out. The payoff odds for any, and then there's payoff against and there's payoff for. So I chose to do this, the way I read it, it's payoff odds for the event occurring. You take the amount of the bet and then put it in a ratio or an odds with the net profit. So in this example then, the amount that I'm betting is $10. Okay. My net profit, you take the $500 you win minus the original $10 you bet. Okay, you have to subtract off that because I don't want total profit, I want net profit. Net profit is going to be $490. And if you reduce that, you get odds of 1 to 49, okay, which is answer A. Okay. Now, again, there are a lot of other things that you may recall or not as you go through, but start looking at some of these exercises. Go through and do what you can. Send me an email if you got or really hung up on one. And then after I get enough questions on problems, what I'll do is I'll go ahead and put together another little video working through those examples. Okay, and then we can talk a little bit about, or I can tell you a little bit about what the intent was, etc. So give those a try. There will be handouts for the next chapter available tomorrow, so don't forget to pick those up. Okay, so this worksheet, however, this review won't be due until next Friday. Okay, thank you.